the three different graphing techniques where we had standard form, intercept form, and vertex form, right? Today, what we're going to get into, you've already covered, and I know the teachers last year would have stressed this. So if you know how to do it, fantastic. If you don't, make sure you're taking good notes today because most of it should trigger back in your head. So what we're going to be looking at is solving quadratic equations in the form of ax squared plus bx plus c equals 0. And actually, this isn't true. We're going to be dealing with, we're not going to necessarily be dealing with the a yet. That's what we're going to be dealing with. So if you notice, what's my a up here? What's my coefficient on x squared? 1. So that's where we're going to be starting. Okay, the next section is going to be the ax squared plus bx plus c, which is when a is not 1. And what I'm going to be doing is I'm going to be teaching you something called the LaRue method. And the LaRue method only works if you know how to factor these down already. So this section is really, really important because you're using the skills from today in 4.4. Okay, so please make sure that you are paying attention and you know what's going on with the basic functions so that way we can get into the more advanced functions. Okay, everybody good? Yes. So who remembers this? What form is this in? The equation that I've written on the board on the left. What form is that? Standard. Okay, now I'm going to factor, right? What does it mean to factor something? Like, what are the factors of 12? Yep. 1 and 12, 2 and 6, 3 and 4. Okay, so what's 1 times 12? What's 2 times 6? What's 3 times 4? So those are factors of 12 because you can multiply them together and get back up to 12, right? Everybody okay with that? So factoring is like the opposite of multiplication. So the end of 3.2, what was the multiplication that we learned? What was the F? FOIL, right? This is going to be the opposite of FOIL. Everybody okay? So when we're working with quadratics, we're going to go from standard form into what's called intercept form, which basically means we're going to create two factors. All right? So who remembers from last year, when you're factoring, where do you start? A, B, or C? A. So what's my A? X squared. So what I need is I need two items that when you multiply them together, you get x squared. So what is it? X and x, because x times x is x squared. Everybody okay with that? Yes or no? Okay, after A, where do I go? B or C? It's C. Okay, so now what I need is I need factors of 20. So tell me, what are the factors of 20? Okay, okay, then after 4 is 5, which is already on my list, right? So these are my pairings. So I'm either going to use a 1 and a 20, a 2 and a 10, or a 4 and a 5, because these are in my last position, right? So FOIL says to find the C, I have to take the last number in each set of parentheses and multiply them together. So I have to get 20 out. So I have to have a 1 and a 20, 2 and a 10, or a 4 and a 5. Everybody okay with that? Yes or no? Yeah. To figure out which one I want to use, I have to figure out based off my B, right? So in FOIL, you have first, which we just create, right? L, we just create. The O and the I are what determines the B. We're going to take O plus I. Everybody remember that, right, with FOIL? Where you always group that middle term up. So what I'm trying to do is figure out one of these is my O, one of these values is my I, and that's how I get my middle. So what we do is we look at the sign on C. What's my sign on C? Positive, which means that I have to add my factors together and get out my B. So can I take a 1 and a 20, add those and get 9? Can I take 2 and 10, add them and get 9? 4 and 5. Okay, so I know my factors are 4 and 5. So you actually set up the numbers first. A lot of you try to figure out the signs first. The signs come last. Okay? You need your first and your last set up. All right, so now we need to figure out the signs. So what we do is, again, we go back to C. What's the sign on C? Positive. What kinds of numbers multiply together to get positives? 2 negatives or 2 positives. So if the sign on C is a plus, what that means is that the signs inside the parentheses have to what? They have to match. Okay, because a negative times a negative is positive, and a positive times a positive is positive. So they're either both plus signs or they're both minus signs if C is positive. And what they're going to do is they're going to match B. So what's the sign on B? Negative. So both of these are negatives. Now, some of you are going to be multiplying going, okay, I don't know if this is right. What's nice about this is Mathematically speaking, there is no difference at all between this top line and this bottom line. Okay? If I broke 5 into 3 plus 2, is there a difference between the number 5 or the statement 3 plus 2? No, they're both equal to the exact same thing, right? You are factoring here, which means that you're not changing any of the values. You're just changing the way it looks. So what can I do to make sure I'm right? FOIL it, right? What's the opposite of factoring? Foiling. Actually perform the multiplication. So let me check. What's x times x? So what's x times negative 5? Okay, what's negative 4 times x? And what's negative 4 times negative 5? Okay, group up your like terms. F, O plus I becomes your middle, so it's negative 5 minus 4. And then you have your last, which form the 20. Did I get the exact same statement I started with? Then that means that my factors are correct. Do you have to do this and check, everyone? Absolutely not. If you're looking at it and you're like, ugh, I'm not sure, multiply it out and check. If you get the exact same answer out of your FOIL as you started with, your factors are right. If you didn't, then either the signs are off or the numbers are off or both. But you then have to troubleshoot and try and find the mistake. Okay? So this is the analysis we're going to go through. We're going to go from A to C, check which factors of C either add or subtract to get B, set up our numbers, and then for the signs, we'll look at C first and then B. All right, so everybody okay with that? So we go A, C, B, C, B. That's the pattern that we're going to be running through on all of these. So, again, if you notice my lead coefficient is 1. So I set up, so where do I look first? Where's the first place I looked? A, so my A is x squared, so it multiplies together to get x squared. X and x. So I have an x, and I have an x. What's after A? C, so what do I see at C? 12, right? So what multiplies together to get 12? Okay, 1 and 12, 2 and 6, 3 and 4. Those are my pairings, right? Now I have to figure out which of those 3 pairings works. So what's the sign on C? Negative, which means that I'm going to be subtracting my pairings. So I need to take those, subtract them, and get 3. So what's 1 minus 12? Negative 11, right? Is that 3? Okay, what about 12 minus 1? Positive 11, is that 3? Okay, so is there any way that I can take a 1 and a 12, subtract them, and get a 3? Okay, so that means that this pairing doesn't work. Everybody all right with that? So that is not a possible option. What about 2 and 6? So what's 2 minus 6? Negative 4, right? Is that 3? What about 6 minus 2? Okay, is that 3? All right, so this doesn't work. So now I've got 3 and 4. Can I take a 3 and a 4, subtract them in any combination, and get a 3? Okay, so it didn't work for 1 and 12. It didn't work for 2 and 6. It didn't work for 3 and 4. Do I have any other pairs to try? No. So can I perform this operation? No. So, well, we don't have solutions yet. I don't have equals to 0. So I'm just going to put down the only thing that I can, which is cannot be factored, because that's the only thing that I'm actually trying to do right now is factor down this polynomial. So we can't say no solution yet because I don't have an equal 0. I'm not trying to find the solution. I'm just trying to factor. All right? So if you run out of pairs that can form your C, and there's no way to combine them properly to get your B, then it cannot be factored. Now, this can be solved, though. Who remembers from last year? What method do we have that works all the time, even though it's a big beast? Yeah, it's called the quadratic formula, right? The quadratic formula will find the solution to any quadratic out there. Okay, so I could find the solutions to this. It just cannot be factored. Factoring only works with special types of polynomials. It's just that there's a lot of them. Everybody okay with that, yeah? All right, so x squared minus 3x minus 18. I want to factor this. Again, where do I start? How many pieces am I going to get? 2, and they're multiplied together, right? So, like, the factors of 6. 2 numbers and multiply together to get 6 is what I'm looking for. Here, I want 2 items that when they're multiplied together, I get x squared minus 3x minus 18, right? That's all the word factoring means. Make it smaller, so if you multiply the 2 smaller pieces together, you get right back to the beginning. So I've got x and x, right? What are the factors of 18? 1 and 18. 2 and 9. 3 and 6. Does 4 work? 5. And then 6 is already in my list. Yeah, do you all know that's how you know when you're done? Yeah, so what you do is you go in order. If you notice, my numbers are always mathematically in order on the left, right? So you put 1 in the number. Does 2 go into 18? Yeah, so I put it there. Does 3 go into 18? So I put it there. Does 4? Okay, so I skip it, right? What about 5? What about 6? It's already on my list. I'm done. Yep, that's it. So everybody okay with how to form that? Because if you can't form your pairs, you're going to be in a little bit of trouble. Okay? So now what's the sign on C, positive or negative? Okay, so am I going to be adding my pairs or am I going to be subtracting my pairs? Subtracting. So I need 2 numbers on my list for being a factor of 18 that when I subtract them, I get 3. So like, can I take 1 and an 18, subtract them and get 3? 2 and 9? 3 and 6. Okay, so I know my numbers are 3 and 6. For right now, order doesn't matter on those. Okay, 3 and 6, 6 and 3, they mean the same thing for the time being. When we get to the LaRue, it's more specific and precise, so you have to pay more attention, okay? So now we have to sort out our signs. So I look at C. What is the sign on C? Negative. So are my signs inside the parentheses going to be the same or different? Different, which means that I'm going to have 1 positive, 1 negative. Well, which is which? So what's the sign on B? Negative, which means that the bigger factor has to be a negative. What's bigger, 6 or 3? So that means that I need to have a minus on 6, which forces the positive onto 3. All right, so for r squared plus 2r minus 63, you all are going to walk me through this. Tell me what to write. Oh. Well, you didn't say it. Okay, so space. Wait, is that the right one? Oh, so it's a closed parenthesis. Okay. Okay. And then where do I look? So that's my A is already done, right? Okay. So I need 2 numbers that multiply together to get what? Okay, and are we going to be adding or subtracting the factors? Subtract them to get what? 2. So give me 2 numbers that multiply together to get 63, but when you subtract them, you get 2. 9 and 7. For those of you that are like, what is he talking about? Factors of 63. 4 is out, 5 is out, 6 is out, and then 7 and 9. So I'm trying to find one of those pairs, and when I subtract the numbers, I get 2, right? So everybody okay with, we know that 9 and 7 is 2, right? 9 minus 7? All right, so what's the sign on C? Negative. So are my signs inside the parentheses going to match or be different? Different. Okay. The bigger factor has to match B. And what's the sign on B? Positive. So what sign goes with the 9? And what sign goes with the 7? Everybody okay with factoring when the lead coefficient is 1? All right. So the last thing that we need to cover. Oh, shoot. Sorry. We have 2 things to cover. These are special cases. You can either learn the shorthand or not. It's really up to you. The main thing is that I do want to show you a little bit of pattern up here, okay? So how would we normally factor this? A, C, and then B, right? So what 2 numbers multiply together to get A? X and X, right? And then factors to get 9, right? So my factors of 9 are 1 and 9, 3 and 3, and that's it, right? Okay. Now, you know that I have to add or subtract those to get B. Well, what's my B? Right, there isn't one, right? So this really means, if I were to write it out in standard form, really means x squared plus 0x minus 9. So the B is 0, okay? So it's not written, but it's there. So if something's gone, you assume that the coefficient on it is a 0. That's why it's just gone. It's there. You just can't see it because it doesn't have a value. So I need 2 numbers that multiply together to get 9, but when I subtract them, I get what? 0. So the only way that you can have an A and a C with no B is if you have the exact same numbers in both sets of parentheses, one's plus, one's minus. Okay, so this only works when you have an A minus a C. If that's A plus a C, cannot be factored, you're done. If it's a minus a c, it can be factored. Okay, and the number that goes into the parentheses for your last is going to be the square root of your answer. So what's the square root of 9? So you get 3 and 3. And because it's a minus, one's a plus, one's a minus. Okay? So whenever you see a and c, right, you see an x squared minus a number, it's going to be the exact same number in each set of parentheses. One's a plus, one's a minus. If you ever see an x squared plus a c, it cannot be factored. Everybody okay? Okay, so let's walk through this one over here. This one's a little bit more straightforward. What multiplies together to get a? Okay, I need two numbers that multiply together to get 9. This time, what am I doing? Am I adding or subtracting the factors? Adding, and what do I need to get? 6. So give me two numbers that multiply together to get 9, but when you add them, you get 6. Okay, are the signs going to be the same or different? And they're both positive because b is positive. Oh, shoot, that should have been an R. Sorry, I should have used a name. My apologies, sir. Yeah, if the sign on b is a negative and the sign on c is a positive, then they'll both be negatives. Okay, so when the signs match, right, when c is a positive, then both parentheses will match whatever sign is on b. Okay, so these are plus signs because of that. Yeah, that's supposed to be r squared plus 6r plus 9. My apologies. Yeah, no, I'm not supposed to be mixing those. So the only thing that I want to show up here is, what do you notice about the two factors? They're what? They're actually the same. So what I'm going to do is, if you want to write this in shorthand, you can write it like that. All right? Anything times itself is squared. Now, this is the question. Why would I want to write it in this format here instead of in this form or this form? No, just in general. Why would I want to be able to do that? What advantage do I have writing the statement this way instead of in this form or this form? Okay, it's easy to read, but deeper than that. What format is this on top? Standard. How do you find the graph of a line, or sorry, of a quadratic in standard form? You have to mess around with that negative b over 2a and do work, right? What format is this? Intercept form, right? In order to find the x-coordinate of the vertex, you have to do p plus q over 2. What format is this? Vertex. How do you find the vertex out of this? Negative 3, 0. Hey, we're done. Which one is easier to graph out of? Vertex form, right? It finds you the vertex faster, and it's easier to type into a calculator. Why would I want to be able to convert it into vertex form? For speed when I'm graphing. If I gave you this, but your brain finds the pattern and goes, hey, we can go right here, this is a heck of a lot faster. Okay? Again, do you have to use it? Absolutely not. But it's just something that if you see it and I ask you to also graph it, if you have a repeated factor, convert it, rewrite it in vertex form, and just go. It'll save you some time. Everybody okay with that? Yes, no, maybe so? All right, so that's why that's important. Okay. What's the difference between the problems on this page and the problems on this page? Okay, now it says equals. So I'm actually changing the directions without changing the directions. The first 4 problems would have all said factor, right, which just means break it down. What this would say is solve, or it would say find the zeros, or it would say find the roots, or it would say what are the x-intercepts. Those 4 terms all mean the same thing. Zeros, roots, solutions, and intercepts all mean the same thing. Okay? So what does it mean to find a solution? Get what by itself? The variable, right? What's my variable up here for the one on the left? X. So you have to get x by itself here somehow, right? So how do you think we're going to do that? Okay, so what are we going to do first? What's our first step? What's the F word? Factor. Well, we can't FOIL because there's no multiplication up here. So we can't FOIL it, so we're going to factor it, right? So break it down. Now the equal 0 is going to stay out there, so you need to keep that with you. Okay, that's really important. So what multiplies together to get x squared? X and x. I need 2 numbers that multiply together to get 18, but when you subtract them, you get 3. Okay, are the signs on the parentheses going to match or be different? And the bigger one is, it's negative because it's going to match b, so I get a negative 6 and a plus 3. Any questions on how to factor? because we already factored this one. Not yet. So that's the old rules, right? Factor. Now we're solving. So we have to go from factors to solutions, but it's not nearly as bad as it looks. I said just a minute ago, this equals 0 is going to be important. It's going to be important right now. Okay, so first of all, it's important because it's where the term zeros come from, right? You heard me say zeros and roots mean the same thing. Well, whenever I ask you to find a 0, I'm asking you to find an x value, because that's the only one we ever solve for. We don't solve for y's. We solve for x's and then calculate the y's that go with it, because that's a dependent versus independent variable, right? So when I ask you to find a 0, I'm asking you to find an x value that makes y equal 0. That's what I want. So if this statement equals 0 is what I'm trying to find, what's the connection between the left set of parentheses and the right set of parentheses? What's connecting them? Right here. What operator? Multiplication. So real quick, what's 0 times anything? Okay, so if I can make this left side, this left set of parentheses equal 0, will I get a true statement? Yeah. So I'm going to take my x minus 6 equals 0. If I can find a solution to this, then I'll get 0 times something, and this will be true, right? What's anything times 0? Okay, so what happens if I can get the second set of parentheses go to 0? Do I get a true or a false statement? True. And that's what I'm trying to find. So now I have two linear equations, which I know how to solve. So how do you get x by itself here? So what's x equal to? Positive 6. And how do you get x by itself here? So those are your two solutions, roots, zeros, or intercepts. Yes, sir. So the important thing up here is the language, right? This is a quadratic, right? What are these two things called? These are factors. And then what are these? The solutions. You need to know that language. Okay, if I ask you to find factors, you need to know when to stop. If I ask you to find solutions, you need to know when you stop. If I want you to rewrite the statement in standard form, you need to know that means get back up here. So I went from standard form to intercept form to solutions. Or from standard form to factors to solutions. They mean the same thing. Okay? So the language is going to be really important when we get into synthetic division in Chapter 5. Okay? Because we're going to be working backwards. We're going to be going from these back up to here. So you need to make sure that you understand the difference between solution, a factor, and a quadratic. Okay? And that's it. So here's your homework. So hopefully you remember most of this from last year, right? It's one of those things that we're going to be using from now until the end of next year. You're going to do in chapters 8, 13. I think it shows up in chapter 11 again. All right, so factoring is one of those key pieces that you need when you go off to school. All right, regardless of what you're going into, if you have to take any kind of a math class, they're going to expect factoring at some level.